Hello, YouTube. This is Dr. Ronald W. Sachs, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. Today, as with most of my weekly reciprocal systems screencasts, we're going to discuss the reciprocal system. This time, its version of the Titius-Bode relation. So here we go. In the reciprocal system, planetary systems result from the supernova explosion of the parent star. The outward moving in space, relatively slow speed matter eventually reconstitutes as a red giant and then contracts to the main sequence. The inward moving, that is outward moving in time, inward in space, intermediate speed matter constitutes the eventual planets. In reciprocal system terms, the low speed and light matter moving outward is termed substance A, whereas the intermediate speed and heavy matter is termed substance B. Substance A, by the way, all the elements below 26 are iron, and substance B are element 26 iron and all the heavier elements. There are three speed ranges in the reciprocal system: 0 to 1c, 1c to 2c, and 2c to 3c. The intermediate speed range is 1c to 2c. 2c is the dividing point between one-dimensional motion in space, less than c, and one-dimensional motion in time, more than 3c from our perspective. Between 1c and 2c, the velocity equation flips, which means that instead of it being v equals s over t, it's t over s. And the motion is in time for the individual particles. But the object as a whole remains in 3D space and may still have spatial motion so that the total motion is two-dimensional. The speeds are discretized in the units above 1c of 0, 1, 1.5, 2, 3, and 4. This brings the motion to the neutral point within the range of 1c to 2c. Beyond that, the motion is parentheses 4, 3, 2, 1.5, and 1. Thus, there are a total of 11 speeds between 1c and 2c, and thus 11 possible planets maximum in which the matter aggregates because the units are at the same relative speed. Okay? So for the first half, the inner planets, the semi-major axis is proportional to n squared, whereas for the second half, the outer planets, the semi-major axis is proportional to 1 over n squared. Let A0 equal the semi-major axis of the orbit of the closest planet to the star, which in our solar system is Mercury, of course, in units of astronomical units, and let K be an empirical coefficient. This value depends on the amount of substance B and the violence of the supernova, and so has to be determined by iteration over these squares. Now, so for the inner planets, equation 1 here, A n equals A0 plus K times n squared, astronomical units. For the outer planets, A n equals A0 plus K times 288 divided by n squared, astronomical units, where n equals the speed number given above, and the constant 288 comes from matching equations 1 and 2 at the neutral point between 1c and 2c. And you can see reference 1, which is Dewey B. Larson's work, The Universe of Motion. Now, some 7 stellar systems have been studied with the following results. So for the solar system, we have A0, 0.3871 astronomical units, K equals 0.276. Reference 1 gives A0 equals 0.4, and K equals 0.267, but the values given here give a slightly better fit. So again, these two values have to be fit for each solar system. The Gliese 581, A0 equals 0.0282, astronomical units, K equals 0.0124. HD 10180, you can see the values there, HD 4037, 307, Kepler 11, Kepler 186, and Tau Ceti. So please note that these values are for the initial positions of the planets after formation and do not take into account the migration of the planets over time due to clearing of the orbits of debris and the gravitational pull of the other planets. Also, perhaps the K values can be further tweaked. Still, the agreement is quite stunning. Equations 1 and 2 can even be used to predict the existence of other planets for these systems. For example, for Kepler 11, planet positions 3 and 4 are missing. There should be a planet or debris at 0.2178 astronomical units and one at 0.3578 astronomical units. All right, so that wraps it up for today. So you see that the reciprocal system is completely quantitative and mathematical. Study the reciprocal system and prove it for yourself. For the simplest possible treatment, please obtain my work, The Unmysterious Universe. It's only 80 pages long. It has all the concepts, the postulates, it has many diagrams. It really is the simplest possible way to learn the reciprocal system. Now, if you do want all the mathematics, I have my magnum opus, Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. 711 pages in the PDF file and 711 slides in the PowerPoint file. Thousands and thousands of equations, numerous tables, diagrams, everything you need to know about the reciprocal system, fully computational. Now, once you get through that, which will probably take you quite a few months, you'd be ready for the two database modules, the Reciprocal System Microcosmos database and the Reciprocal System Macrocosmos database. Microcosmos database covers all the properties of matter and cosmic matter. Includes properties of photons, subatoms, atoms, compounds, and alloys. All the major properties are calculated by theory, compared with empirical regression equations or the empirical data. Now, the Reciprocal System Macrocosmos database covers all the astrophysical properties of the universe as a whole. Galaxy clusters, galaxies, star clusters, stars, planets, moons, minor bodies like asteroids and comets, nebulae and voids. Very comprehensive. Both modules have lots of graphing capability, etc. So please, study the reciprocal system and prove it for yourself. It is the true theory of the universe. Go forth and learn.